Hello everyone, thank you for joining the webinar today. Throughout the presentation, please use the Q&A feature on the right hand side to submit any questions and Mark will answer them at the end. A quick introduction to Mark. He's the sales director for the first responder side of the business. Mark's been with Avon Protection for 7 years but has experience working with the Argus thermal imaging cameras for 10 years. Today he's going to take you through the principles of thermal imaging cameras.
Morning everyone, and welcome to Avon Thermal Imaging Overview. I know some of you on the audience will already know some of the basics, but what I'd like to do initially is just get everyone on the same level, so we all understand the kind of basic principles of thermal imaging. I'll take you through in a bit more detail the cameras. Presentation is about 30 slides approximately, about 40 minutes, and then followed by 20 minutes worth of Q&A. That may change depending on how fast I go through the slides. And on the Q&A, can you please wait till the end of the presentation and add your questions to the notes, which Abby will read out at the end for me to answer. And nothing's off the table. Please ask questions away. I'll answer as best I can, and if I can't answer the question on the spot, I'll make a note and then come back to you with an email just to answer your query. Okay, so we'll move on to the first slide. So basically, when we look at thermal imaging, we refer to it as the emission of infrared waves or infrared radiation. And what thermal imagers do is they translate that infrared energy into a viewable image. And the way TICs works, or thermal imaging cameras, we call them TICs, they see the contrast differences between different temperature areas, and therefore contrast must exist in an image in order to produce that image. And a good example here is if you look at water with a thermal imaging camera, water tends to be an even temperature, and what you will see if you use thermal images, look at water, is just a very even grey colour, because there is no contrast with water. However, if there was an object floating in that water, there would be a very big differential between the object floating and the water. So the camera would be able to see that contrast, and that residual heat signature can be detected and made into an image. And that's in essence how thermal imaging works. If you look at the three images on the screen here, you can see that very clearly. The one on the right is obviously a residual heat signature, so someone's been sat on the back seat of that car. The image in the middle is obviously a person hiding behind some bushes, and he's emitting infrared energy. And then of course the image on the left is a very hot fire with some contrast differentials there with regards to the chairs and the other objects within that image. And that's how in essence a TIC manufactures or produces an image. So if we look at the basic principles of thermal imaging, infrared is part of the electromagnetic spectrum, and it's actually just beyond visible light, just beyond the red end of visible light on the visible light spectrum, but it's considered invisible because you can't actually see it with the naked eye, and that's why it's called infrared. All objects emit IR in different ways, and in some instances infrared can be detected when visible light can't, and hence it's used in smoke and for the fire industry. So again, you can see in the image there on the right hand side of the screen that visible light has a relatively short wavelength compared to infrared. And what happens with a visible light when it's traveling through smoke is it bounces off the smoke particles and gets absorbed, so you can't see through the smoke. Whereas infrared light has such a long wavelength that it can find its way through the smoke particles and to the detector. So in effect, the detector can see the light or the infrared light transmission through the smoke and convert that into a picture. Infrared is transferred in kind of three ways really: conduction, convection and radiation. And it can also be emitted, absorbed and reflected, and I'll talk a bit more about that shortly. So Moving on from the previous slide, I want to talk about what emissivity is and why it's important. So basically, emissivity is a measure of a material's ability to emit infrared energy. And traditionally, it's a measure from 0 to 1. And if we take something like wood, wood has a high level of emissivity, 0.9. So it absorbs a large portion of the infrared energy and then emits that energy. Whereas something like stainless steel, which has a polished surface, has a very low emissivity. In fact, stainless steel has an emissivity of 0.07. And what you must be aware of as a TIC user is that, in essence, shiny objects with low emissivity, like stainless steel or like a mirror or like glass, will reflect the infrared energy. So if you were to use your infrared camera, your TIC, to look at a mirror, you would just see the reflection of yourself. And that's important to bear in mind when you're an operator using the TIC, because different objects will produce different images depending on their material makeup. And that's quite important. And the example I'll use is if you take a gas cylinder, for instance, that's made of steel, it will have a very different emissivity to a piece of furniture that's burning in a fire event. And so you need to be aware of that, because that will give you some difference in results in terms of what the camera sees. And as a trained operator, you need to be aware of things like gas cylinders and how they look on a thermal imager. As I mentioned before, there tends to be three types of infrared for us. There's what we call passive, and passive is has the ability to no ability to generate their own heat. So these objects are heated by active or direct emitters, and the picture on the left, of course, is a hand that's on a wall. So these sensors on our cameras are very sensitive. So you can hold your hand on a wall or an object for a fraction of a second, and you will get a handprint that you can see with the thermal imager, and that can last a considerable length of time. Actually, not so much in the fire industry, but certainly in the forensic industry, quite often forensic scientists use that effect of passive infrared to detect where someone might have been, or whether a door's been opened, or whether someone's been keying in something on a keypad, because strong passive energy can last many minutes. The middle picture we see there is active. An active infrared energy is a medium kind of level infrared heat, and it's emitted by living things, so people, animals, myself, and you can see these very clearly. But the highest energy source, of course, is what we're probably most interested in, is what we call constant high strength emitters, and that would be fire. And these, like the sun, like a naked fire, give off huge amounts of infrared energy and lots of contrast because of that. And so you can see those direct emitters very clearly on a thermal imaging camera. So just the principles of thermal imaging, and this is very similar to what you would see in a traditional visual camera, not just a TIC. So on the left hand side of the screen, and fairly unique to the Argus brand, we have what we call a lens window. And the lens window is made of a germanium ceramic, and the germanium is invisible to infrared. So the infrared energy passes through the germanium window, straight through the lens and onto the sensor. Now, the important thing about the germanium window is that protects the front end electronics of the camera. And actually, if I show you that on the front of this camera, this is the germanium window here, and this is actually a user serviceable part. So you can pull this window off and change it, because this is the bit you point at the fire, and this is the bit that tends to get damaged if you lay it down in a fire situation. So that's quite an important thing because it protects the sensor electronics and the lens behind this. So when this gets dirty, which it will get fire, soot, smoke particles on there. You can wipe it with a cloth and you've cleaned your camera. So it's a very important part of the camera is this window, and it's user serviceable. Behind the window is obviously, like any camera, is a lens that directs the infrared energy or infrared waves or light waves onto the sensor. And then the sensor obviously has a focal point like a camera. Traditionally, we focus our cameras at up to 4 meters. And we use a focus chart to do that, but they can be focused at 1 meter should you be required to get closer to an object. Traditionally, 4 meters is about as close as you want to get to a fire, so that's why they're focused there, but we can focus them closer if there's an alternative use for the camera. So the lens focuses the infrared energy, the infrared light, onto the sensor, which we call a microbolometer. But in between the lens and the microbolometer is what we call a calibration shutter. And when you switch one of our TICs on, and actually this is right for the whole industry, when you switch a TIC on, we need to calibrate that sensor and to make sure that it's producing an image that's accurate. So every 15 or so seconds, when you switch the camera on, the shutter will flick in front of the sensor. I'll do this, and the shutter will flick in front of the sensor, calibrate, and then flick out. That happens over 300 milliseconds. It's very quick. It doesn't slow the picture down. It doesn't cause any lag. So in the first minute, that happens every 15 or so seconds. And then eventually, when it's settled down, it's calibrated, it does every minute. And you'll hear it just click for a fraction of a second, and that's the calibration. So the next stage, of course, is the microbolometer, the sensor. That's the clever bit, and that's the most expensive part of the camera. We buy our sensor from Ulysse in France. Actually, the company name's changed, and I can't remember what that is. And that's they're manufactured in Grenoble in France. And we've been using their sensors for many years because they're of the most highest quality, and we get to access the image. The clever bit behind the sensor is the processing electronics, and we've got 2 types of processing electronics. We've got the detector interface, the bit that takes the microbolometer output and converts it into the numbers that we can process. And then we've got the display interface, which gives us a display on our LCD on the right hand side. All of our LCDs are very high quality, industrial grade, high temperature LCDs. They're not your standard phone LCDs. These are expensive LCDs. For obvious reasons, they need to resist very, very extremes of temperature, and they need to be rugged enough to use for the span of the camera, which is usually a 10-year life cycle. So we would expect the displays to at least last that long. And we surround them with the rubber bumper, as you can see there on the image, just to make sure that if the camera's dropped or it experiences some overheating, then the display's protected. So how do we derive an image? And this is the interesting part, and we're going to talk about the sensor here. So every microbolometer has a natural variation that resides permanently on the sensor, because the sensors are grown, they're silicon devices, and so they have a granularity. And image B is an example of that granularity when we put the shutter that I described earlier in front of that sensor. So what the sensor has done there in image B is taken a picture of the shutter with no scene in the background. So the shutters come in front of the lens, in front of the sensor, and it's a piece of metal that the image is just taken. And you end up with the picture of the sensor, the granularity of the sensor. When you remove the shutter and take a picture, you get image A. So image A is whatever's in the scene plus the granularity of the sensor. And then what we do is we take one image from the other to derive image C, which is basically image A less the granularity image B to give you the image in the scene without the granularity of the sensor. So there you get a very clean image. We do that very quickly. So each image A and B, is taken at a 60th of a second to derive image C, which is at a 30th of a second. So it's quite often on a bid you get asked, how quick is the camera? How often does it take a picture? Actually takes a picture every 60th of a second, but presents that image at every 30th of a second. So there are some issues there. Quite often in the bid, some people will say 60th, some people will say 30th, and you have to interpret what they're asking you. Is it how often you take an image onto the shutter, or how often do you display that image? So we talked about principles of thermal imaging and thermal contrast. And as I described earlier, thermal contrast refers to the temperature differences between objects within the scene. And thermal contrast must exist to produce a thermal image. And high contrast situations produce images with greater detail that are easy to interpret. So the reverse is opposite. Low contrast situations, and we talked about water earlier on, and how water is just a uniform temperature, and so there's no contrast. But low contrast situations produce images with lesser detail, and so little or no tactical information. And what we have to do is we need to interpret those images that require high levels of shape recognition by the TIC user. So low contrast scenarios are typically driven by environmental factors, so uniform heat, as in water, or uniform cold, as in ice, for instance. So we use dynamic scene enhancement to digitally adjust the images, and in particular in these low contrast situations, so that it enables the operator to see the detail in a whole scene. And if you look at the image in the right, you can see there is an absolute blazing fire in the background, and you can see that fire is measuring it. It's in Fahrenheit there, and not centigrade for you Europeans, but you can see that in the fire there, we're measuring it at 1,844 Fahrenheit, which is close to 1,000 degrees Celsius. So that's an incredibly hot fire. But you can still see the detail outside of the fire and away from the fire. So you can see the two office chairs there. You can actually see that one chair has fallen down. You can see the fan on the right-hand side desk. You can see the wardrobes on the left-hand side. And these are all things that for a firefighter walking into a scene, and what you have to remember is this scene is with the naked eye, there is zero visibility because that will be covered in smoke. They are trip hazards. They are things you could fall over. They are things you could bump into. They are hazardous to you trying to go in there and save life or to fight the fire. The other important thing is you would be able to see your entry and exit point. So if there was a door or a window that you needed in an emergency, if there was a flashover situation and you needed to exit quickly, you'd need to be able to see where those things were. And so where we use dynamic scene enhancement, and I'll talk about this in a slide or two, is to clear that image so that you can see the fire very clearly, but you can also see everything else in the scene, your trip hazards, etc., and maybe casualties. And the way we do this is very clever, but we need to understand a few things about that first. So we need to understand what we call gain modes, and gain modes are prevalent in every thermal camera. Everybody has one or has several. Most cameras on the market have a 2-sense gain mode, and most cameras on the market will operate in temperatures between around 0 degrees and up at around 550 to 650, depending on the type of camera you buy. We like to think we are better at doing this than most, and we have a 3-sense mode camera. So the dynamic range on our cameras is a lot higher. We can measure temperatures up to 1,100 degrees centigrade, and that's important, and I'll go on to explain that. But the way we do it is we change the sensitivity of the camera sensor during those temperature increases. So And I'll liken it to a very easy comparable. On a normal camera, whether it's your phone camera or a normal visual camera, if you pointed the camera at the sun, you would have to adjust the sensor, and on a normal camera that would be the ISO that you would adjust to make a good picture of the sun, because it's very hot. Likewise, if you took the same camera and you looked at a picture of water, which is cooler, you would have to change the sensitivity of your camera sensor to look at the water to get a good image. And we do that dynamically, and we use gain modes to switch through the different sensitivity modes of the camera. We switch from high to low gain modes. And as you can see, the kind of scales on the right hand side there, you can see where those 3 gain modes are. So on the left hand one, at kind of 0 to around 200 degrees is the first gain mode there, and we call it high gain. Then from 200 to 550 is gain mode 2, and from 550 to 1000, well, 1100 degrees is gain mode 3. On the 2 cents one, you've got a kind of 0 to 525, 550, 0 to 250 to 300, and then from 250, 300 to around 550. And in the case of a FLIR camera, it will go up to 650. But that's it, you're limited to that range, and that's it on a 2 cents mode camera. So in very hot fires, and we did see an example of the fire earlier, which was measuring close to 1000 degrees Celsius, you would just see a red out. And that's important. So basically, we automatically adjust the gain either in 2 mode or 3 mode, depending on whose camera you're using, to enhance the scene. So what we need to understand is the dynamic range and the definition of dynamic range, and all detectors have a maximum dynamic range. So our sensors will measure from 0 degrees to 1100 degrees Celsius, or in the image on the right here, 0 degrees Fahrenheit to 2000 degrees Fahrenheit. And once you hit that top end of your sensor's capability, that's exactly it. You're hitting the top end of your sensor capability, and you run out of room to present a clear image. So if you're in a situation where your camera will only do the 2 gain modes, and you're measuring a fire above 650 degrees Celsius, your sensor is maxed out. Your sensor's capabilities is hit the end stop, and so the image that will present is going to be pretty much like that. It will be fully red. Now, we all know on this call that flashover temperatures occur around 650 to 700 degrees, depending on the type of fire. When things are pyrolyzing, gases are rising to the ceiling and they're getting hotter and hotter and hotter, around 650 to 700 degrees, that's when a flashover could potentially occur. If your camera reds out at that temperature ceiling, it's useless for your safety. And so we pride ourselves in understanding that and realizing that actually you need to measure well above those flashover temperatures. So in that 1% of situations where it's dangerous to life, you have a tool that allows you to still see your entry and exit points and trip hazards, and potentially find areas of safety when an event becomes very dangerous. So we very much advocate a bigger dynamic range for that reason. This is a great example in this image of a flashover occurring, and I just want you to watch the right hand screen and watch the temperature rise in the bottom right hand corner. This is in Fahrenheit. You can see the flashover occurring there, and very quickly the temperature escalated from 740 degrees right up to 1600 degrees very quickly. The left hand image is what you would see with the naked eye, so you can see there's pretty much very little visibility. And in that situation where you can see that happening, you need to be able to navigate very quickly and very safely out of a situation. Now you can see that camera on the right hand side, and this is a TIC. You can still see the chair in the foreground there. You could still see casualties on the floor. You could still see if there was a trip hazard, even though the flashover is occurring. And at that moment in time, you would be there making a decision about whether you should stay in that environment or not. And I suspect most firefighters would want to be removing themselves from that scene as it builds. Now, this is an extreme situation, and the reality is that you would be gas cooling the hot gases that are causing that flashover well in front of this event occurring. But if you were in that incident at the time and you had a camera that was completely redded out, i.e. you couldn't see anything in that scene because your sensors hit its end stop, the tool would be useless for your safety. So that's why the high dynamic range really comes into its own, where 3 gain modes come into its own, and where the dynamic scene enhancement that we use allows you to see not just the fire, but the detail in the scene for your safety. So representing firefighters, we supply the clearest and safest image. So a quick history lesson. So we've been developing cameras for over 40 years. Some of you will know the history, but I'll basically go through it. So in 1979, the camera on the left was first developed and by a company called English Electric Valve, or E2V, as some of you will know the company. And we built the first ever handheld thermal imager. Although we said it was handheld and you could hold it by your hand, it weighed a ton, and we still have one in our museum, and it still works all of those years later. But that was the kind of the MOD, a UK MOD, Ministry of Defence, had asked us to develop that camera to see through smoke, basically, but it was shelved. Nothing was ever done with it. We didn't think it was a project that was going to move on. The MOD didn't buy significant numbers of them, although they funded the development for it, and that was it. But where it really came into its own was in 1984, when the Argentinians invaded the Falkland Islands and the UK went to war, unfortunately, with the Argentinians. One of our ships, the HMS Sheffield, was hit by an Exocet missile and was burning for 6 days. And the problem with ships is when they're hit by missiles is they black out. And everybody knows here a naval vessel is huge, and you've got to be able to navigate round that ship to find life, to fight fires when there is a blackout, zero visibility. So in 1984, when the HMS Sheffield was hit and was on fire, the MOD remembered the camera that we'd developed in 1979 and asked us to ship 6 of those cameras down to the Falklands, which we did. We actually flew them on a Hercules. They were parachuted out of the back of a Hercules around the HMS Sheffield, so they were waterproof, and they were picked up by the teams that were trying to navigate around the ship to find life and to extinguish the fires. HMS Sheffield burned for 6 days, and in the end they had to scuttle the ship, so they had to drill holes in its hull to sink it. That was the only way they were going to do that. But the interesting thing is, at that moment in time was the birth of thermal imaging for firefighting. So we've been in the technology from day one, and we've developed a range of cameras, as you can see there, from day one. If we move down the range, you can see what looks like a steering wheel. We call that the Argus 3. The one before it, actually, the black one just to the left of it, was the first transistor thermal imager. And as you can see, at that point in time, thermal imagers started getting a lot smaller from the ones on the very left, which were all valve technology and vacuum tubes for displays. We moved then to transistor technology and transistor displays, very early transistor displays. The one to the right of the steering wheel, as we call it, is the Argus 4. It's one of our best-selling cameras. The Argus 4 was when we opened up the sensor resolution to 320 pixels by 240 pixels, and we called that the Argus 4 HD, high definition. And that became the industry standard. And there was some lessons learned on the Argus 4 about how we presented the image, and that's where we began to discover that we could manipulate the image to give the user the scene that they were looking for, i.e. great picture of the fire, but also a great picture of the scene. And that's where dynamic scene enhancement really started to take shape. And then of course in 2012, due to the Shirley Towers incident in the UK, where we lost a firefighting team who weren't carrying thermal images, the British government did an independent inquiry into the loss of life, and it was recommended that every firefighting team, every BA, breathing apparatus team or wearing team, should all have a thermal imager. So we wanted to develop the very smallest and lightest thermal imager, and along came the MyTIC. Its design was based on what we could fit in a tunic pocket. So we wanted the camera to be small and light enough and of a shape to go into a firefighter's tunic pocket, and that's why, and still today, it's still the smallest and lightest camera, and that's why it looks like it does. Ergonomically, it's very well balanced. For those of you who've already used it, you can hold it very nicely between your thumb and your forefinger, and you will feel the weight transmission between the battery and the sensor and the display is really nice. Naturally, you put your thumb over the buttons and it's not difficult to hold with a hand glove, and the buttons are designed to be easy to press with a gloved hand, but also have some feedback so that you know that you press them. You can feel them click with your gloved hand, and that's quite important to understand. This is a very balanced camera to use. It's not top heavy. A lot of TIC on a sticks tend to be very big displays, very light handle, but they're top heavy, so you get repetitive strain injury quite often, whereas this sits very nicely in your hand, as you can see as I'm holding it. So the Argus range, let's move on nicely to the Argus range. We have 4 cameras in the range. The MyTIC E, the yellow camera, is the lightest and most cost-effective thermal imager. It's a smaller screen than our flagship. It's a 2.7-inch screen. It's still a good quality display at that small size, but where we like the MyTIC E is that it's designed for those budgets that potentially don't need all the bells and whistles of the top of the range camera, but want a thermal imager for everybody. MyTIC EL, similar to the MyTIC E in that it has the same functionality, but it's a bigger screen. So if you've got a BA team, 2 users, and you've got 1 camera between you and you both need to look at the camera, you've got that larger screen to look at the camera. And we have the MyTIC 320, which is the again a 2.7-inch screen with lots of bells and whistles on this camera, so slightly different dynamic range, and I'll go through those shortly. And then we have the MyTIC S, which is the top of the range. So I think you can see there that we've got 4 cameras and they really do suit all budgets. So the MyTIC S on the right is the top of the range, that's the most expensive camera, and the MyTIC E on the left is the bottom end of the range. Still a very high quality camera. It's the same casing and the same electronics. That's what you've got to remember. And what we do is we cut down all the functionality and the features of the MyTIC S, so you get a very high quality but cost effective camera. So if we go through the standard kind of features on these cameras, so all of the sensors and all of the displays are 320 by 240, and a quick technical note on those cameras. We have a 1-to-1 relationship with the sensor versus the display, and that's important. So our sensors are actually, I think they're 388 by 288. I can't remember the exact resolution. So the sensor resolution is actually greater than the display itself, which all the displays on these cameras are 320 by 240. But what we do is we crop the sensor to give it a 1-to-1 ratio. So 1 pixel of the sensor corresponds to 1 pixel of the display. What that means in terms of image is that you get a direct relationship between sensor and display. So no lag when you pan across an image. So if I was to pan across on some cameras, you get a ghosting effect because the display has to catch up with the DSP that's trying to reduce the size of the sensor image to fit on the display. We don't do that. We have a one-to-one relationship from the sensor to the image. So when you scan, you will see no delay and no ghosting on the image. Again, a really important feature, because if you're in a situation, as I've just described with the flashover, and you've got to do a quick scan to find your exit point, and you get a ghosting or you get a stutter in your image, you may miss something during that image. So it's important that your image refreshes very quickly. We have a spot temperature measurement as standard. That is going to be changing in the new NFPA 21. So that will be a feature that we add. So the NFPA organisation don't want a spot temperature moving forward. So we will put that on another mode, which I'll talk about in a minute. We have a field replaceable germanium window, which I talked about briefly. And then we have configurable buttons for standardizing operations. The green button is always an on-off button, and it's also always the NFPA button. So the green button, when you press this button, doesn't just switch the camera on and off, it actually also takes it back to the NFPA fire attack mode. So if you've got confused about what your camera's telling you, press that green button and it takes it straight back to a very well and familiar known mode that every firefighter should know. These cameras black box record. So if this camera is sat on your chest or on your pocket and it's got black box record enabled, it's videoing the minute you switch it on. Videos in 10-minute chunks, and so you can access that. We have a desktop charger, which I won't show you, but that's a charging station as standard, so you don't need to buy that as an optional extra. It is an optional extra if you want to, but it comes as standard with one. We have a 3-hour battery life, although we are looking at changing that shortly. We're looking at new battery technology at the moment. So in the next 3 to 6 months, we should definitely have a new battery technology that will give you in excess of 4 hours. The good thing about our batteries is they are lithium iron phosphate, capable of over 2,000 charge cycles. It's very rare we get a battery back. They're certified and warranted for 5 years, and more importantly, they're intrinsically safe. So the safe to take complaints. They don't thermal run away, so they're not going to explode in your hand like lithium ion. So it's a safe battery technology. All of our cameras, all 4 cameras, as you can see in the image there, are NFPA 18001. Shortly, we're going through certification at the moment for the latest NFPA. So NFPA 1801 FY or 2021. So we're hoping end of July, early August, we should have that new certification. So they're currently certified to 1801 2018 right now. So in the next few months, they'll be certified to the latest NFPA. Again, probably unique for us in the industry. And then we have different dynamic ranges depending on which camera you buy. So the dynamic range for the MyTIC E and EL, the yellow cameras, is 0 to 760 degrees, again, just above flashover temperatures. And then the red cameras have a dynamic range of 1,100 degrees, so 0 to 1,100 degrees Celsius for those very difficult fires that people attack. Some of the advanced features on the right-hand side there are hot, cold spot trackers, image freeze, image capture, video capture, an electronic compass and laser, and they feature on the red cameras, the MyTIC S in particular. So I'll just whistle through the key features. So we have several application modes. There's actually 6. So fire mode, overhaul, size up, inspection, and I'll go through this in a bit. White hot and heat seekers. So we'll look at those. We've got 2 and 4 times digital zoom, image capture, so thousands image stills, and depending on the size of SD card that we put in the camera, can give you up to 16 hours of video. And of course, if you running black box, that just records all the time. We've got a laser pointer on the S and image freeze. The laser is at the top. This is a 1/4 watt laser, and once you switch it on, it stays on for 10 seconds. And that's the legislative ruling on a laser. So obviously, if it shines into someone's eyes, it could potentially damage them, but ours won't. And the idea with a laser, it's designed just as a pointing device for you to point things out as you're using the camera. It's powered by the Ignis engine, and this is our latest sensor versus processing technology. We've moved from a 25 micron sensor to a 17 micron sensor, so a much more compact sensor, which gives increased image quality at higher temperatures. So the hotter the fire, the better the camera looks, the better the image looks, and that's important because at the end of the day, that's what these cameras are used for. They're used for fighting fire. Class-leading battery technology, I described that with a 5-year warranty. 320 by 240 resolution, and on the Mighty S is a big 3.5-inch screen, and customizable startup screens as well. I won't go through all of these features, but you can assign a splash screen onto the front so that when you switch the camera on, it can do one or two things. For a reseller or a distribution partner, it could have your contact details on there. So when you switch that camera on, it could say Chelte or Rosenbauer or whoever it wants to say. It could also say the name of the brigade that's using the camera and which appliance or pump or fire truck that the camera belongs to. So quite a nice kind of feature. 3-button operation. Now, all of these cameras come in 2 or 3-button operations. Obviously, there's a slight price differential. So depending on what you want your user to be able to do, depends whether you go for a 1-button or a 3-button. So under a kilo, very small, lots of rubber on these to keep them safe. The material it's made of is called Ridsdale, which is a chemical and heat resistant casing, so very, very ruggedized, and this will plug into your PC and you can see what's happening on the camera. There's lots of feedback. There's even the user instructions are actually embedded on the camera, so when you plug this into your USB slot on your laptop or your PC, you can see all of the data on the camera, including the user manual and also the warranty as well. And then finally, the Mighty S offers the highest dynamic range, as we described before, up to 1100 degrees. Okay. So I won't go through all the cameras. That's the Mighty S. But what I want to quickly try and finish off on now is some information about the application modes. I'm conscious that we're into 40 minutes on the call. So there are 6 modes on the camera. The first one being fire mode, and this is usually used to attack large-scale fires or big structural developed fires. And the reason being is this uses the full dynamic range of the camera, so the full 1100 degrees of the camera. And you can see in the image on the left, the hot coloration comes in on the training bar there, and this is in Fahrenheit at around 1000 degrees Fahrenheit. Everything starts to turn yellowy orange, and you can see the very hot stuff is red. So in that image on the left, you can get a very good picture of how hot that fire is. You know that the red bit of that fire is around 15 to 1600 degrees Fahrenheit, and in the case of Celsius, well in excess of 900 degrees Celsius. So that's a hot fire, and that looks like someone's garage or garden shed. So you can see very quickly that, you know, limiting your dynamic range to 650 degrees or under those flashover temperatures is not going to be a useful tool for you. So it's important from a sales point of view to understand that. The middle mode, the size up mode. So what we do here is we deliberately limit the dynamic range. So what we're looking to do with that image there is to, usually from outside a scene, from outside a structural fire, make sure that we're sizing up the mode correctly, and then in overhaul after a scene, we'd like to check the fire for secondary reignition points. 3 other modes. Missing person mode, very straightforward. Image on the left there shows you a person hiding behind a bush. Basically, the hottest part of the scene is coloured blue. So if you think back to the water situation I was talking about earlier, if there was someone floating in the water and you used this missing person motor, fire teams are often used for water rescue or ice rescue. You would see that the ice in the water, be a uniform temperature, would be grey, and anything hotter than that, and it only needs to be a fraction of a degree, would be blue. So very quickly you'd be able to spot someone. White hot mode is a standard mode for many thermal images. So whatever's the hottest in the scene is the white, whatever's the coolest is black, and then the grayscale in between. And then inspection mode is a mode we use to watch heat dissipate through an event, and also for those resistive elements in circuit boards, etc. White's the hottest and black's the coolest again, and then a rainbow of colors in between. On the high range cameras, the TICs, we have hot and cold spot trackers. Interesting use of these, and there are various uses for these hot and cold spot trackers. We can have them on independently, we can have them on together, depending on how you set the camera up. So the hotspot tracker or the heat seeker goes to the hottest part of the scene, simple as that. And you would expect it to go to the hottest part of the fire, which on the left hand picture there you can see absolutely does that. Again, still seeing the detail in the scene. And on the right hand side, the cold seeker would go to the coldest part of the scene. Now in this case, you can see it's gone to the first stage reducer on the firefighter's SCBA there. Which is useful. So if you think you've got several teams in a fire situation fighting that fire in a zero visibility situation, and you want to see where your teammates are, it would very quickly go to the bottom of their first stage reducers, because that's going to be the coldest part of the scene. It could also be used if there wasn't other people in the scene for probably detecting an area that's the coolest in a scene and potentially has the most oxygen in a scene. So if you were in a rescue situation where you had casualties that were maybe unconscious and you needed to drag them to an area of the scene that potentially was cooler and had potentially more air or more oxygen, you could use a cold seeker for that as well. So there's some quite interesting uses of a hot and cold seeker. Image freeze, this is a great one. Basically, on a single press of the button, you can take a picture of the image and it freezes that image. Firefighters tend to use this. That's a casualty that you can see lying on the floor there. What we've done with that image is that actually we weren't in the container of that image. What we did was open a door, put the camera behind the door, took a photograph of the image, brought it outside the door. So we've not committed a fire team to that event, and basically looking at the image to assess the situation before we enter the event. Now that's a situation where there's a small fire in the back there. This is a container fire, and this is part of our training when we learn about thermal images. And that's a dummy on the floor there that's representing a casualty. But you could see now that you can make very quick decisions about what you do before you enter that event or enter that scene. You would want to go in with probably a stretcher to pull the casualty out, and you'd want a team to go in and just extinguish that fire. So you've already made decisions about what you're going to do before you commit a team into an event. That could be something else. That could be a room full of gas cylinders about to go off. And again, you would make a different set of decisions. So this is all about making a decision before you commit a team to an event. On the dynamic scene enhancement, this is where we describe how we manipulate the image to give you the clearest and safest view. So bear with me on this one because it's quite difficult to explain, but in our opinion, the clearest and safest view is when you can see the detail in the fire, as I described earlier, but also you can see the rest of the scene, and you can see those together, not one or the other. And examples of details in the scene may be trip hazards, we talked about those, overhead hazards. We know that when fires get hot, any cables in the ceilings will melt and sag. And they can be trap hazards, they can be snag hazards for your SCBA on your back, they can get caught in your helmet. You want to be able to see casualties. You know, when you commit a fire team into an event, their primary job is to save life. You want to see those exit and entry points. You want to see any gas cylinders or any obstructions, and that's the interesting thing. So we liken this to if you was to take a photograph of someone with a normal camera who's got the sun over their shoulder. With a normal camera, you would get a very good picture of the sun because that's where the camera would focus, but the person would actually black out. You wouldn't be able to see that person. But if you did the opposite, took a picture of the person, you'd get a good picture of the person, but the sun would be so bright, it would be you wouldn't see any detail in it. Where we dynamically enhance the scene is so you can see both. You can see a very bright sun, and you can also see all the detail on a person. And we liken that to the sun representing a fire and the person representing the scene. So what you want to do is you want to see both. You want to see a clear picture of the sun or the fire, and a clear picture of the person or the scene. And we dynamically adjust the scene using processing to enable that. And that's why you can see a very clear picture of the fire in our cameras, but also a very clear picture of the scene. And the graph on the right hand side there describes how we do that. And I'm not going to talk through it because I'm conscious that we're running through on time, but please ask questions if you need to at the end of the presentation. So just some of our certifications. Of course, we're CE certified. We manufacture in the UK, so we're CE certified for the European market. We're also CSA certified for the US market as well. And also we're NFPA certified to 2018. And as I described earlier, we're currently embarking on our 2021 certification, which we're hoping to have end of July, early August at the latest. We're actually going through it right now. And that's a really important certification for us and for the fire industry. And then a few last points, warranty and support. The cameras come with 10 years warranty on the sensor and lens. They come with 5 years warranty on the battery. And then the camera itself, the MyTIC has a 5-year warranty, and the yellow cameras, the yellow cameras have a 3-year warranty, and the red cameras have a 5-year warranty. So actually what that means is that we have the most extensive warranty package on the market, and the camera should not cost you anything during its 10-year life. The exception being you might have to buy a new battery after 5 years. But in our experience, actually, the batteries are lasting. We're not seeing those batteries coming back. So we think the cost of ownership is the lowest on the market. So you buy the camera, it comes with everything, including your truck charger and your lanyards. You get the most extensive warranty package, and most fire cameras are designed to last 10 years, and the industry keeps a camera for 10 years and then moves on. So we think we offer a very extensive warranty package for those cameras. Just a couple of more slides to go. We also have a partner portal for everybody who's a reseller on the call. That partner portal gives you all the information about product, approved imagery that you can use, and logos that you can use on your own social media platforms or on your websites. All the product certifications, sales tools, etc., are all on that. And there's also details of our partnership programs and any co-op program for marketing co-op that you'd like to look at. And you can contact our very own Julia Daniels for that information. Her email address is there. So please log into the partner portal if you haven't already done so. There's a wealth of information about the cameras. You can pretty much answer most of your questions just by going onto the partner portal. And of course, if you don't get what you need, you can always contact me. Just go through the team, the Argus team. So as explained earlier on, I'm the sales director for Europe and Asia Pac, and my responsibility is to sell the product. But we have Darren Wolf and Tom, they're both the product managers. Darren's over in the US and supports a global role, actually, as Darren, and Tom mainly supports us in the EMEA region. And then we've got Phil Bassett on the section. He's responsible for lots of things, but basically for manufacturing quality and also for repairs turnarounds when cameras come to the factory for repairs. And may I just say that we very rarely get cameras in. It's a very robust product, as those on the call all know. And then we've got John Turner, who's our technical specialist. I think that's it from me. So let's go to some questions. Thank you for listening. So
first question, why is dynamic range so important?
Okay, so that's back to about where flashover occurs. So well, there are two reasons. One is at around 700-ish degrees, and when I say ish, every fire officer will tell you slightly different. But there is a situation, what we call flashover, that occurs when a scene gets so hot that everything in the scene, whether it's the desk I'm sat at, the chair I'm sat at, pyrolyzes. And what I mean by pyrolyze is that the gases, the makeup of your surrounding bits of furniture, your carpets, off gases. And those gases, they get hot and they raise into the ceiling. And as they get hot, they become explosive. And usually around, as I showed you in the video, they're usually around 706 degrees, those gases explode. If you can't measure above that with a high dynamic range, you can't see the scene. Your sensor reds out. And that's really dangerous, because in the 1% of the time that you're in a dangerous situation, you need that dynamic range of your sensor to make sure that you can still see where you're going and what you're doing and make decisions very quickly about how you should get out. So that's one aspect. The other aspect is, if we take naval fires, for instance, naval fires are usually in steel containers, because that's the essence of a ship. It's a big steel container. And in naval fires, quite often it has to do with ordnance, explosive chemicals, metals that burn very hot. So and they burn well in excess of a flashover temperature. So the magnesium alloys that you get in ordnance, those kind of metals, they just burn incredibly hot. So again, you get fires in excess of 1,000 degrees Celsius that you need to be able to see both the fire and the detail in the image for your safety. And so high dynamic range is absolutely imperative on a camera.
Thank you. Why did you stop producing Argus 4 in the future?
Yeah, so the problem with Argus 4 is that it's over 20 years old, the Argus 4, and we love the Argus 4 camera. It's a great product for us, but it became obsolete. Many of the components within the Argus 4, even down to the battery technology, just became obsolete. We couldn't supply half of what we needed to in the camera, and so we had to move on to a new platform, sadly. And people still like to buy the Argus 4, but as we move on, we do support it still, but we just can't supply some of the parts in the Argus 4, and that's in essence why we had to move off the platform.
Thanks, Mark. Another question just popped in on that, so I'll jump in. Do you have any available stock of the Argus 4?
Not really. So we kind of do, but it's for a specific customer who I can't talk about, of course. But no, if you were to order an Argus 4 now, we wouldn't be able to supply it. We would entertain it if it was for hundreds of Argus 4s, and we would potentially think about it then. But the reality is there would be a lot of redesign work. There'd probably be some certification work to do. So the reality is probably not.
Thank you. How much percentage of FOV and temperature degrees will make the sensitivity mode be changed?
Okay, so FOV, field of view. So just read that one again. I need to answer that in several stages.
How much percentage of field of view and temperature degrees will make the sensitivity mode be changed? Okay,
yeah, that's a really technical question now, and I understand what you're saying. So for those on the call who are listening to that question, so when you look at the field of view of the camera, the number of degrees, your human eye has a field of view of 50 degrees, and our camera is exactly the same. So it's a 50-degree field of view. And I think what this question is asking is, how much of a field of view does the heat affect? How much percentage of that to make the sensor adjust its sensitivity? I think that's what that question is asking, and the answer is, off the bat, I couldn't tell you, unfortunately. So I'd have to ask that question and come back to you. But please do email if you've got the contact details for that question, and I'll go back to them. Okay, please send me your contact details, and I'll answer that question. That's a very technical question, but it's a good one.
Great, thank you. Sorry, we've got quite a few questions coming in.
Cool.
Will the new batteries, be compatible with the old MITIC, the pre-Ignis MITIC?
Okay, the answer there is yes and no. So the old batteries are not compatible with the new cameras, is what I'll say, and I think the new batteries are compatible with the old cameras. I think that's the way around. Again, I think I'll answer that. I'll get one of the engineers to answer that. We had to change the plastics very subtly because during the NFPA test, there is what we call a 6-axis test. So on the NFPA test, they have to bounce it on 6-axis, and the battery has to stay in position. Now, those of you will know the early MyTIC cameras, the battery was slightly easier to get on and off, and that's because the plastics were slightly different. But in the new NFPA test, and this was the 2018 test, they changed that battery test slightly, so the battery can't fall off during that 6-axis test. So we had to change the plastics slightly, so that means the old battery is not compatible with the new camera. But I think the other way around, I think it's perfectly fine. But again, I'll check and confirm and answer that question via an email.
Okay. Do your cameras have a black box record, and what is it used for? Why would you use it?
Yes. Yeah. So basically, when you switch the camera on, depending on how you set the camera up, you can set it to black box record, which means that it's videoing all the time from the minute you switch it on. It videos in 10-minute chunks, so it's continuous, but it's in 10-minute file sizes. So say, for example, you know, at 3 o'clock in the afternoon, you have an event, you go into a scene, you commit a fire team, and you know, at 3:15, a flashover occurs. And that sadly damages one of your team members, and he has to be rushed off to a hospital or whatever. You may want to produce that video in an inquiry or an event. From a training point of view, you may want to look at that afterwards and see what happened during the scene. So the idea with black box record is that you're keeping a record of that event visually without thinking about it. And that's really useful. Now, it's very similar to what the police do with body-worn cameras. They have their cameras running all the time, and basically it allows them to watch a scene. I don't know if anybody watched the recent George Floyd court case, where they were using body-worn cameras and cameras used by the public actually to look at the scene and assess how the police behaved during that event. Very similar to black box record on these cameras. I hope that answers your question.
Thank you. If there are ongoing tenders requesting 4 hours or more battery time, can we say yes to the requirement, since its availability may be quite soon from what was presented?
Yeah, so the answer is you'd need to talk to us about that, because it's all based on time scale. So we have recently done a tender, in fact this week, where we said yes to 4 hours, but we need to understand the delivery time scales, because the batteries have to go through certification, of course, both NFPA, which we're doing at the moment. We are certifying those batteries for NFPA at the moment, but they also need CE certification and the US certifications as well, and they take some time. So basically, if you do have an inquiry for 4-hour plus batteries, we can tick that box, but we need to understand and make sure that we're aligned with regards to the timescale on delivery, because if you want it next week, the answer is going to be no, but if you want it in 3 months' time, the answer is probably going to be yes. So we just need that heads up.
Thank you. And another question on battery: why is there no longer a 5-hour battery anymore? Yeah, so and that's basically supply and demand. So the 5-hour battery was the large battery, as everyone remembers it, and the problem is 99% of the sales of batteries were the standard battery, and we had a 1% sale. So actually what we're trying to do is get to the 5 hours with new battery technology that's of the same form factor as we have now, and that's what we're experimenting with. So it was all about supply and demand. We couldn't get enough enough demand for that battery to warrant the supply, and so we had to move away and consolidate the battery technologies. When will you launch the LRT with MyTIC?
Okay, so again, that's an interesting. So we have an almost finished product in the LRT, and I have demonstrated it to some people. Works really well. Gives us about 1 kilometre worth of line of sight video distance, which is great. It's a rugged device. Again, we're back to, we need to see some inquiries, and until we see some significant inquiries, we can't do. We can't move any more, and there's in Europe there's a significant reason. Everywhere in every country in Europe has a different frequency that the emergency services operate on, and this is a microwave device, and there is legislation for every country for that frequency. So it needs to be cost effective for us to do that. So yes, we have a prototype product. If there are genuine, fairly large inquiries for those products, then we will entertain it. So if anybody needs a demonstration of that product, I can give them a demonstration, but we need to have quantity to move forward with that.
Perfect. So another question: are you going to produce a thermal imaging camera which can be equipped on the fire truck?
Are we going to produce a thermal imager that's equipped on a fire truck? Okay, so I'm not quite sure what you mean there, but I'm gonna kind of talk to it anyway. So in a fire truck, there tends to be two thermal images, and several thermal images actually, but two that I'm aware of. The one is the handheld that you actually fit inside of a fire truck, and if I quickly show you our truck charger here, basically this truck charger would fit on the bulkhead of a fire truck, and then you would insert your camera inside it, and then it would charge constantly. And then when you go into an event, you get out your fire truck, put your SCBA on, take your camera, press the button, and away you go. And this truck charger remains in the truck. That's one version of thermal imager. The other one is on a ladder or a platform, depending on what kind of fire truck you're operating on. Quite often they will have a thermal imager on the end of the ladder that feeds a display that's actually in the cab of a fire truck. Really good example of that is, anyone remember the Notre Dame fire in Paris, where the French fire brigade, the Parisian fire brigade, had long ladders trying to put water over the top of the ceiling. Actually into the cathedral itself. They had thermal images on the end of their ladders, obviously beaming pictures down to the cab. Sadly, they weren't long enough. Now we have got a black box prototype of that device, and again, it is potentially a product that we could do something with. However, again, it's about numbers. So in order for us to deliver that product and certify it and to NFPA-ify it, we would need significant quantities. So like most manufacturers and most products, we need the quantities to warrant the return on investment to develop those products. So the answer is yes, we potentially could, but we don't have a product right now. And if we did do one, it would have to be significant quantities.
Thank you. We've got lots of questions about future development, so you may or not be able to answer this.
Yeah.
But I'll kind of merge two together. One is, will Argus have a new camera soon? And another is it able to add Wi-Fi connection on the MyTics in the future to transmit the view onto a smart device? Okay,
so I'll answer that in two bits, and the first bit I can answer very easily. So the LRT system, the long range telemetry system that we have, the new prototype that we can demo freely now, and again we need quantities to finalize that product, already has Wi-Fi. So you can already take the image from the camera and put it on your smartphone or your tablet. It actually has an Ethernet connection. So as long as you've got Wi-Fi Ethernet, you can display it on any device anywhere in the world. It's a really useful part of the system. We have trialed it with some fire brigades where they use it in their command and control vehicles, and they can beam those images wherever they want. So it's quite a powerful system, very easy to use. So the answer on the Wi-Fi is yes. With regards to new cameras, I can't tell you what we're doing with new cameras, but what I can tell you is that we constantly develop new products. So we're constantly looking at technology. We're constantly taking feedback from the industry. And there are two significant challenges. Depending on which country and which fire brigade you talk to, they will say, we're just happy with a TIC, very simple use, one button, and that's it. and then you speak to another fire brigade and they want Wi-Fi connectivity, Bluetooth, they want it to tell them how much air they've got in their cylinders. So depending on who you speak to depends on what kind of a product they want. So the answer is we are constantly looking at what customers want. And at some point, I would imagine that we will make a decision and deliver a new product. But right now, we're still in that investigation / development stage. So that's as much as I'm prepared to say right now.
Thanks, Mark. And I think this question you probably just answered as well in the same sense. Any plans for helmet-mounted TICs in the future?
Yeah.
But I think your answer there.
Holy Grail.
Then here, do you have a new soft carry case designed to fit the MyTICs?
We actually did a soft carry case for I think it was the New York Fire Team, and we also did one for the Royal Navy as well. They were quite unique. Actually, the problem with carry cases is quite often fire teams all want different types of cases, and we have to be very careful what we commit to. So we do have several carry cases that are detailed actually in the price book. That would be a specific inquiry, because we tend to have those made outside, not by ourselves, and we buy in. So again, we're back to, unfortunately, economies of scale. They're very expensive if you just make 10 of, but if you make 1,000, then they're easy to justify. So again, that's really about an inquiry and making sure that it works for us and works for you. So I'd be interested in that inquiry through an email if someone would like to send me that.
Another question on how do you clean the MyTIC? Do you need any special cleaning liquid or kit, or do you just use water? Yeah,
soapy water, that's it. There's nothing special about cleaning this product. It's IP67, so it's fully waterproof. It's vacuum tested when it leaves the factory. And so, yeah, just wipe it over with a damp cloth, bit soapy water, nothing more than that, no special chemicals.
Thank you. Questions seem to be coming down, but we've got two more. Why is the colour of the fire in a mirror still showing as yellow or red? Should fire in the mirror be no temperature?
Okay, so that's all about emissivity, and so basically, you've got to think of it in terms of normal visual light and not infrared. It behaves in the same way. So this is a good example. So if you're brushing your teeth in the bathroom in the morning, when you look in the mirror, you will just see yourself back. And that's in essence exactly what the thermal imaging or thermal energy does. So if you as a person are an active emitter, an emitter, you emit an infrared energy, it's reflected by the mirror, and all you see is yourself back. So depending on the temperature of the image you're seeing is dependent on what's being reflected back. So if it was a mirror, for instance, or very polished stainless steel, if you were emitting 1,000-degree infrared energy or image, that's exactly what you'd see. So it behaves like a mirror. You're just going to get back what you put into it.
Thank you. In the search mode, if a person's temperature is covered by the thick, hot smoke, can the thermal imaging camera still show the person's image? That's
a yes and no question, that is. So in my experience anyway, and the training events I've been into where we've mimicked rescuing casualties in a fire situation. So you can see a fire moves, they're not static. The flames moving in and out of each other, gaps appear, and you can see through fires. So you can see through a fire, but it depends on its intensity and where someone would be positioned. So you can see through, but that's the skill of the firefighter and the training that's gone on one of these to see that. I showed you an image earlier of a person sat behind a tree, and he was coloured blue, and it's those gaps that you get that you can just see well enough. So yes, if it was a very intense fire scene, you were absolutely right, it would block. body temperature at 36 degrees or whatever body temperature you would be at. But there would be those thermal gaps that you can see through, that quite often you can see the outline of a person, and that's my experience.
Perfect, thank you. We'll just wrap it up with this one last question. Why are there so many colour modes? Isn't that confusing for the firefighter? Okay, so two things. So not all cameras are used for firefighting, or fire attack, should I say. Some cameras are used for electrical devices. So I'll give you a really good example. So I once was asked to go to Wembley Stadium in the UK, not to watch the football, sadly, but just to check they use a hydroponic system for the grass, to grow the grass in Wembley Stadium, believe it or not. And they wanted me, and they use these enormous fans and these enormous lighting systems. And they wanted me to check the cabling, because they run cables all the way around the stadium, and they wanted me to check the cabling for shorts, for resistive elements within their system, just as a potential hazard. So I used the kind of the mode on the camera which showed you all the rainbow colours, and we call it inspection, just to see which cables were hot, which weren't. And we actually found one fan was drawing too much current, and the cable was it looked to glow white hot, and that was a potential fire hazard. So we potentially prevented a fire. So not all cameras are used for firefighting. So that's why we have so many modes. But when you configure the camera, if you know where that camera's going, you can take all of those modes off. You could just have one mode if you wanted. Most people use 3: fire attack, size up, and overhaul. The 3 modes that you would use in a fire situation. 1 before the event to size up the event, 1 after the event to make sure there are no secondary reignition points, and then fire attack, which is the one you use in the event when you're going into a scene and you're trying to fight fires and save life. Hope that answers your question. Brilliant, thank you, Mark, and thank you all for joining today. So what I'm going to do is send a follow-up email including the presentation in editable format as requested, so that it can be translated into your local language. I'll also be sharing the recording of this presentation, including Mark answering your questions, and there'll be the link to the portal for any additional information that Mark mentioned, and also Mark's contact details. So if you did have any further questions or want some clarification, then you can get in touch with Mark directly.
Thank you very much all. Have a good day.